Okay, we're going to start today's lesson 6.4 on double and half angles. The nice thing with this is that you will get to have these formulas in front of you. So it will be on the formula sheet that you will have for your test. The formulas are sitting here. Let's just get started. So we are looking at first to use the angle sum formulas to develop new ones. So I'm going to use my sum formula for sine, which would have been sine x, cosine x, plus cosine x, sine x. We will notice these are exactly the same terms, and that does wind up to be 2 sine x, cosine x, which does then become the sine of 2x. So that's just the development of the double angle formula for sine. Cosine has 3 different formulas to use. It doesn't matter which one you choose. Just some are more helpful than others depending on the problem. We're just going to develop the first one of cosine squared minus sine squared x. So again, if I use the double angle formula for cosine, we would have cosine x times cosine x minus sine x, which would get us cosine squared x minus sine squared x, which then it becomes the cosine of 2x. And lastly, we'll develop the double angle for tangent. Again, where alpha and beta are both x's in this case, so this would be tan x plus tan x over 1 minus tan x, which would simplify 2 in the numerator, 2 tan x over 1 minus tan squared x. So that's how those formulas are developed. So let's see how we're going to use them to help us solve some problems. Okay, so it tells us to find the exact value of sine of 2u, cosine 2u, and then tangent. And it tells me that the tangent is equal to negative 15 over 8, and that we are sitting here in quadrant number 2. What we're going to do is develop our triangle. This will be angle U. Tangent is opposite over the adjacent. And again, in quadrant 2, the x is negative, the y is positive. This is a Pythagorean triple, letting us have the hypotenuse at 17. Alright, so I want to find the exact value of sine of 2u. The formula would be 2 sine u cosine u. So 2 is 2. If I look at the sine, that would be the opposite over the adjacent, so that's going to be 15 over 17. The cosine of u would be the adjacent over the hypotenuse, or x over r, so that would be negative 8 over 17. And when we multiply all this out, you will get 240 over 289. Good news here too, guys. We're going to let you use calculators for this section because some of these numbers get a little crazy. Alright, that's sine 2u. So let's find the exact value of the cosine 2u. I'm going to use the formula cosine squared u minus sine squared u. So we said cosine is negative 8 over 17 squared minus the sine, which is 15 over 17 squared. That gets me 64 over 289 minus 225 over 289, leaving us with negative 161 over 289 as our exact value. The last one we're going to work on here is tan 2 theta, or 2u. And that's going to be, the formula I'm going to use is 2 tan u over 1 minus tan squared u. They did give us the tangent here. It is negative 15 over 8. So we're going to have 2 times negative 15 over 8 all over, let's see here, 1 minus negative 15 over 8 squared. That gets us negative 30 over 8 all over 1 minus 225 over 64. Again, once you get these embedded fractions like this, the easiest thing to do is to cancel out the denominator. So I'm going to multiply all three terms through by 64, being the lowest common multiple of 8 and 64. Here, 8 goes into 64 8 times, and 8 times negative 30 would get us negative 240 in the numerator. 64 times 1 would get us 64. And the last term, the 64s would cancel out, minus 225. This then would simplify to negative 240 over negative 161. And lastly, the two negatives would cancel out, leaving us with a value of 240 over 161. Alright, so that's one example of a problem. We're going to verify some identities with these as well, just like we covered in the last unit. Again, you will have the formulas in front of you. So I want to show that the cosecant of 2 theta is equal to the expression on the right side here. Cosecant is 1 over sine 2 theta. And sine 2 theta is equal to 2 sine theta cosine theta, but 1 over sine theta is the same thing as cosecant, and we are there with our identity proven here. When I look at B, I see a difference of 2 perfect squares, so this is factorable. So we're going to have cosine squared theta plus sine squared theta over cosine squared theta minus sine squared theta. This identity here is a 1 equivalent. And that would lead us to our formula of cosine 2 theta. Alright, so those are our double angle formulas. Let's move on to our half angles. So flip your papers over. Okay, these are all the formulas here. You will notice both sine and cosine have a plus minus out in front. You're going to have to decide based on what sine the actual original angle is. So for example, if you look at problem 3, I'm looking at a 15-degree angle. Sine is positive at 15 degrees, so I would take the positive one here. So you do need to be conscious of that for both sine and cosine. Okay, so you will have the formulas in front of you, and I want to use a half angle formula. So I want to know what is the sine of 15 degrees, and I say, okay, I want to pick an angle that is on my unit circle. So I'm going to change this to be the sine of 30 over 2, and that would get me 15 degrees. So again, 15 is positive, so I'm going to use the positive formula here for sine. I'm not going to put the plus out in front. So it's going to be 1 minus the cosine of 30 all over 2. The cosine of 30 degrees is square root of 3 over 2 all over 2. Again, we want to wipe out those denominators, so multiply all 3 terms inside of here by 2. 2 times 1 is 2. The 2's cancel here and here, leaving me with minus square root 3. 2 times 2 is 4. 4 is a perfect square, and our final answer will then become 2 minus the square root of 3 all over 2. Alright, for tangent, I want to know an angle that is on my unit circle, and anything divided by 8 is not on that unit circle. That will get me 9 pi over 8. If I took 9 pi over 4, remember dividing by 2 is the same as multiplying by a half. That would get me 9 pi over 8. 9 pi over 4 is on the unit circle. So I'm going to work this one as the tangent of 9 pi over 4, all divided by 2. Alright, throwing that into the tangent formula, I'm just going to use the one on the top. You can choose either. I find it easier just to have a single term in the denominator, though. So 1 minus the cosine of 9 pi over 4 all over the sine of 9 pi over 4. Now 9 pi over 4, if you're on your circle, it'd be 4, 8, 1 more would get you 9. So it is coterminal with pi over 4. Both the cosine and sine at this point is going to be square root of 2 over 2. Wiping out those denominators, multiplying all three terms by 2. 2 times 1 will get us 2. The 2's will cancel here, and the 2's will cancel on the bottom. Last thing we need to do is rationalize, which is going to get us 2 square roots of 2 minus 2 all over 2. All these 2's on the outside of the radicals will simplify, and the final answer will be square root of 2 minus 1. Lastly, for cosine, remember with sines and cosines we need to decide what the sign is. If we're looking at 7 pi over 8, that would put us over here in quadrant 2. Cosine is negative in quadrant 2, so we're going to use the negative cosine formula here. Also, 7 pi over 4 times 1/2 would get us 7 pi over 8. And again, dividing by 2 is the same as multiplying by 1/2. So we're going to use the cosine of 7 pi over 4 divided by 2 as our half angle formula. Again, we said we're going to use the negative, and we're going to have 1 plus the cosine of 7 pi over 4 all over 2. At 7 pi over 4, that's going to put us over here. The cosine is positive square root of 2 over 2. Wiping out those denominators, put this up over here, keep my negative, so I'm going to have 2 times 1 again is 2. The 2 cancels here, all over 4. And again, 4 is a perfect square, so we're going to have minus 2 plus the square root of 2 all over 2 as our exact answer. And it is okay to have the radical inside of a radical for your answer. Okay, let's move on to problem number 4. We're given that the cosine of mu is negative 3 over 5, and that it is sitting in quadrant number 3. Oops, gotta get the pen working. So there's our angle. We know that cosine is negative 3 over 5. This is also Pythagorean triple. Both x and y are negative in quadrant 3. I need to figure out which quadrant u over 2 is going to be sitting in. So if this is u, just pick any angle in quadrant 3. So for example, 200. If I divided that by 2, that would give me an angle of 100, which would move me into quadrant number 2. So u over 2 is in quadrant number 2, and for the cosine is negative in quadrant 2. So we're going to use the negative formula for the cosine. So I want to have the cosine of u over 2, and the formula here we decided it's going to be the negative 1 over the cosine of u over 2. Well, the cosine of u is negative 3 over 5. I'm going to multiply here everything through by 10 to wipe out both the 5 and the 2. So 10 times 1 is 10. 5 goes into 10 2 times. Multiplying back, we get minus 6. All over 20 there. Let's reduce everything down. by 2, so I'm going to have 10 minus 6 is 4 over 20, and that's going to reduce to 1 over 5, which becomes 1 over square root 5, and rationalized, our final answer would be negative square root of 5 over 5 for the cosine. Alright, so let's take a look at the tangent formula. So for tangent, and let's put up our triangle again. We were at negative 3, negative 4, negative 5, positive 5. Alright, so the tangent of u over 2 is equal to 1 minus the cosine of u over the sine of u. Cosine, the two negatives are going to become a positive, and the sine would be negative 4 over 5. I'm going to multiply everything through here by 5 to wipe out those denominators. 5 times 1 would get me 5. 5 cancels here. 5 cancels here. We wind up with 8 over negative 4, and our final answer for tangent of u over 2 would be negative 2. Alright, moving on to problem number 5. I want to find the exact value here. So this negative 1 up here is telling me to find an angle whose sine is negative 3 over 2, remembering from previous units that sine has to come from quadrants 1 and 4. Since it's negative, we are pulling an angle from quadrant number 4. The 2 stays the 2, and I'm going to use negative pi over 3 as the angle. So then I want to evaluate the cosine of minus 2 pi over 3. So the cosine of minus 2 pi over 3. Remember, for cosine, the negative gets absorbed, so we're looking at the cosine of 2 pi over 3, and the cosine at 2 pi over 3 would be negative 1/2. Alright, we're just going to do a little simplifying and verifying. We'll be done with this lesson. Let's see. The sine of 2x, I just want to simplify this. This is the same as 2 sine x cosine x, and the tangent of x over 2 would be 1 minus cosine x over sine x. Again, you will have these formulas in front of you. These two sines will cancel here, and just multiplying through, distributing through, I get 2 cosine x minus 2 cosine squared x. Factoring it back out doesn't help me simplify anymore, so that's as far as we can go with that one. If I look at verifying to make cosine 10x into 2 cosine squared 5x, I notice that 2 times 5x would get me 10x. I'm going to use the double angle formula here. So this is going to be same as 1 plus the cosine of 2 times 5x. So using one of the cosine formulas, 1 is 1, that's going to change to 2 cosine squared of 5x minus 1. These guys cancel out, and our identity is verified. Alright, good lesson today. We will pick up next time with solving some equations.